Right, this is Unit 10, Lesson 4, Inverses and Determinants. Our lesson essential question is, how do you find and use an inverse matrix? At the end of this lesson, you'll be able to find and use the inverse of a matrix. Example 1, explore inverses of 2 by 2 matrices. What is the inverse matrix of 2, 1, 3, 0? An inverse matrix of a matrix ABCD is a matrix WXYZ such that the product of the two matrices is the identity matrix. So I want to write the equation for the inverse. I use my original matrix times my WXYZ. You don't have to use those variables. You can use whatever variables you'd like, equals the identity matrix, 1, 0, 0, 1. I multiply the matrices on the left side of the equation, so I get 2W plus Y, 2X plus Z, 3W plus 0Y, and 3X plus 0Z, which equals 1, 0, 0, 1. Solve the equations that result from the matrix multiplication. Set each element of the first matrix equal to the corresponding element in the second matrix. This results in a system of 4 equations. 2W plus Y equals 1, 3W plus 0Y equals 0, 2X plus Z equals 0, and 3X plus 0Z equals 1. Solve the equations that involve only one variable first, if you have any. 3W plus 0Y equals 0, so that equals 3W, so W equals 0. 3X plus 0Z equals 1, so 3X equals 1, so X equals 1/3. Now I can substitute W and X into the first 2 equations, which yield the following. 2W plus Y equals 1, so Y equals 1, and 2X, where X is 1/3, plus Z equals 0, so Z equals negative 2/3. So the inverse matrix is 0, 1/3, 1, negative 2/3. I can verify the solution by multiplying my inverse by my matrix, which does give me the identity matrix. So the inverse matrix of 2, 1, 3, 0 is 0, 1/3, 1, negative 2/3. What is the inverse matrix of 1, negative 1, negative 1, 1? I find a matrix WXYZ so that 1, negative 1, negative 1, 1 times WXYZ equals 1, 0, 0, 1. I multiply the matrices on the left side of the equation, which gives me W minus Y, X minus Z, negative W plus Y, negative X plus Z equals 1, 0, 0, 1. I create a system of 4 equations for the equal matrices. W minus Y equals 1, negative W plus Y equals 0, X minus Z equals 0, and negative X plus Z equals 1. To solve, I combine 2 equations that contain the same variables. X minus Z plus negative X plus Z equals 0 plus 1, so 0 equals 1 yields an untrue equation. This system, therefore, has no solutions. Some matrices don't have inverses. The matrix 1, negative 1, negative 1, 1 does not have an inverse. All right, so let's try it. What is the inverse matrix of 1, 5, 1, 3? So I start by writing the system. So 1, 5, 1, 3 times W, X, Y, Z equals 1, 0, 0, 1. Now I can go ahead and multiply through, so I get W plus 5Y, X plus 5Z, and plus 3Y, and X plus 3Z equals my identity matrix, which is 1, 0, 0, 1. Okay, now I can come up with my equations. So I have W plus 5Y equals 1, W plus 3Y equals 0, X plus 5Z equals 0, and X plus 3Z equals 1. From here, I can actually go through and start solving. So I'm going to deal with these 2 equations first, the W plus 5Y and the W plus 3Y. So what I'm going to do is I'm going to solve these 2 equations for W, and then I'm going to set them equal to each other since they'll both be equal to W. So W plus 5Y equals 1 is going to become W equals 1 minus 5Y. And W plus 3Y equals 1 or equals 0 becomes W equals negative 3y. Okay? I can then set them equal to each other. So 1 minus 5y equals negative 3y. I move the negative 5y by adding it to both sides. So I get 1 equals negative 3y plus 5y, which gives me 1 equals 2y, which tells me y equals 1/2. I can do the same thing with the next two equations. So I can solve for, that's supposed to be x. So I get x plus 5z equals 0 is going to become x equals negative 5z. And then x plus 3z equals 1 is going to become x equals 1 minus 3z. Then I can set those equal to each other. So negative 5z equals 1 minus 3z. Move the negative 3z to the other side. So negative 3z plus negative 5z plus 3z equals 1, which gives me negative 2z equals 1, and then z equals negative 1/2. Okay. From there, I can take what I know about y and z, and I can substitute them in so I can find w and x. You can pick any of the 4 equations. So I can pick the 5y or the 3y, or I can do, for x, I could do x plus 3z or y plus, or x plus 5z. I'm actually going to choose the one where they're set equal to 0 just because it'll make my life a little bit easier to solve. You don't have to. You can use the other equations. It's fine. So w plus 3y equals 0. I know that y is 1/2. Okay, so that means w plus 3/2 equals 0. So w equals negative 3/2. And then the other one, x plus 5z equals 0. So x equals 5 is negative 1/2 equals 0. So x minus 5/2 equals 0. So x equals positive 5/2. Okay. Then I just set up my matrix. So w was negative 3/2. X was 5/2. Y was 1/2. And then z was negative 1/2. Concept: the inverse of a 2 by 2 matrix. For A, where the matrix is A, B, C, D, the determinant of a 2 by 2 matrix A, denoted DETA, is the value AD minus BC. The inverse of A is denoted A to the negative first power and exists if and only if DETA does not equal 0. So the determinant can't be 0. If A equals ABCD and A has an inverse, then A to the negative 1 equals 1 over DETA times D negative B negative C A. Example 2, find inverses of square matrices. What is the inverse of A equals 4, 1, negative 1, 2? The matrix is a square matrix, a 2 by 2. The inverse exists because DETA equals AD minus BC. So AD minus BC. 4 times 2 minus 1 times negative 1, which equals 9. So the inverse of negative 1, or the inverse of A, equals 1 over DET, the determinant, times the matrix, the inverse matrix, 2, negative 1, 1, 4. Okay. So I have 1/9 times 2, negative 1, 1, 4 equals 2/9, negative 1/9, 1/9, 4/9. So the inverse of A is 4 of A when it's equal to 4, 1, negative 1, 2 is 2/9, negative 1/9, 1/9, 4/9. You can, of course, check your work by using your calculator to multiply A by the matrix you found for the inverse of A. If your answer is correct, the product will be the identity matrix. What is the inverse of B when it's 6, 8, 3, 4? The matrix is a square matrix, 2 times 2. since DETB equals AD minus BC equals 6 times 4 minus 8 times 3 equals 0, the inverse matrix does not exist. What is the inverse of C when it's a 3 by 3 of 1, 2, 1, 0, negative 1, 0, 2, 1, 4? The matrix is a square matrix of a 3 by 3. The formulas that we have shown are finding the determinant inverse matrix apply only to matrices that are 2 by 2. Use a calculator to find the determinant and inverse of a 3 by 3 matrix. Since DETC equals -2, the inverse exists. The calculator shows that the inverse matrix is C, the inverse of C equals 2, 7 halves, -1 half, 0, -1, 0, -1, -3 halves, 1 half. All right, so 2, does each given matrix have an inverse? If so, find it. So I need to figure out the determinant. So the determinant is -4 times 3 minus 2 times -6. So this gives me -12 minus -12, which is -12 plus 12, which equals 0. So the inverse of P does not exist. For Q, I have 7, 3, 2, 1. So my determinant is 7 times 1 minus 3 times 2 equals 7 minus 6, which equals 1. So the inverse does exist. So that is 1 over 1 or just 1 times B, which is 1, negative B, -3, negative C, which is -2, and 7. Okay, so 1 over 1 is just 1, so that is my inverse matrix. Okay, and then the last one is a 3 by 3 matrix R, 5, 1, -1, 2, 0, 5, 1, 0, 2. So I'm going to go ahead and substitute that into my calculator, or in this case, Desmos. So I'm going to do a new matrix. So this is 3 rows, 3 columns. Okay, 5, 1, -1. 2, 0, 5, 1, 0, 2. That is my new matrix. Okay, so there's A. I want to find the DET of A, so I click on the DET button. Enter. The DET is 1, so it does have an inverse. And then I'm going to click this A to the -1, which is just the inverse. I gotta click A. So A, which is my matrix, and then I'm going to do the inverse, and it gives me the inverse of 0, -2, 5, 1, 11, -27, 0, 1, -2. Okay. So R to the -1, or the inverse of R, is 0, -2, 5, 1, 11, -27, and then 0, 1, -2. Example 3, use a matrix inverse.
Use matrices to encode and decode the message, "We come in peace." Matrix multiplication can be used to encode and decode messages. The first step is to convert the message into a string of numbers. Assign every letter in the alphabet a number, from A equals 1 to Z equals 26. Let 27 represent a space between words. The next step is to choose a matrix that has an inverse to encode the message, like this one, for example. The encoding matrix is a 3 by 3 matrix, so break the message into 3-digit strings. The message doesn't evenly break into groups of 3. The E is left over. To make another group of 3, insert 2 more spaces. Create a matrix from these strings. Now you can encode the message by multiplying the matrix representation of the message by the encoding matrix. Just as A encodes the message, the inverse of A can be used to decode the message. Multiply A inverse by the encoded matrix. The product is the original matrix. The inverse of A decoded the message.
All right, let's try it. The matrix -3, -5, 11, 6, 130, 105, 106, 65, 323, 269, 205, 128 was encoded using the matrix A equals 2, 1, -2, 5, 3, 0, 4, 3, 8. What is the message? So the first thing that I need to do is figure out what this inverse of this matrix is. So I'm going to go back to my little handy dandy Desmos. I'm going to create a new matrix. That is a 3 by 3. And I'm going to enter in what my matrix was, which was 2, 1, -2, 5, 3, 0, 4, 3, 8. Here I'm going to find my inverse, which is 12, -7, 3, -20, 12, -5, 1.5, -1, 0.5. You can also change it to fractions with this handy little button. Okay. So from here, I'm going to take the encoded message and I'm going to multiply it by my inverse. So I'm going to create another matrix, new matrix C. This is a 3 by 4 matrix. Okay. So -3, -5, 11, 6, 130, 105, 106, 55, 3, 269, 205, and 128. Okay, so this is my new matrix, C. I'm going to take the inverse of B and multiply it by C. So B inverse times C. I get this matrix here. 23, 12, 5, 1, 5, 15, 27, 20, 27, 22, 13, 8. Now what I need to do is change these numbers back into letters. So remember when they said originally you've given each letter a number. A is 1, B is 2, C is 3, D is 4, so on and so forth. So what I actually did was I made a little chart at the top of my paper, which I can show you. There's my little chart. Oops, there it is. So it gives me all the letters and what numbers they are. Okay. It's not really super neat. It was kind of written very quickly, but from there I can decode the message. So 23 becomes W, 5 becomes E, 27 is that space. Remember that space there, and so on and so forth. So when I decode this message, I get W-E space L-O-V-E space M-A-T-H. We love math. Example 4, use determinants to find the area of a triangle. How can you use vectors and determinants to find the area of a triangle? So the first thing I want to do is create the triangle using vectors. Orient the triangle so that one vertex is at the origin. Use the vectors AB and CD that result from the two sides of the triangle so that each side has an endpoint at the origin. Then I can form a matrix. My matrix is AC, B, D. So my A and C are my X values, and my B and D are my Y values. Okay, then I just compute the area. Remember, the area of a triangle is 1/2 the base times the height. So what I've created is actually a rectangle. So I'm going to take the area of 1/2 C minus A times B minus D. So I'm taking the determinant and multiplying that times 1/2. So the area of the triangle can be found by subtracting the areas of the surrounding triangles from the area of the rectangle. If you compute the area this way, the result is that the area of the triangle is half the absolute value of the determinant. So what is the area of the triangle defined by the vectors 3, 4, and -1, 2? Vector matrix is T equals 3, -1, 4, 2. Again, my X values are in my top row, and then in my bottom row are my Y values. The determinant, the absolute value of the determinant of T equals 3 times 2 minus 4 times -1, which gives me 10. The area of the triangle is 1/2 times the absolute value of the determinant, so 1/2 times 10 equals 5. So the area of the triangle is 5 square units. All right, let's try it. 4A. Find the area of the triangle determined by the vectors -2, 10, and -1, -5. So the first thing I want to do is find the determinant of, so I want to turn this into a matrix. So T equals -2, -1, 10, -5. Okay. Then I want to find the determinant, absolute value of the determinant of T. In this case, I get the absolute value of -2 times -5 minus 1 times 10. This gives me -10, +10, minus a -10, which equals the absolute value of 10 plus 10, which equals 20. Area of the triangle is 1/2 times the absolute value of the determinant of T. So in this case, it's 1/2 times 20, which equals 10 square units. For B, find the area of the triangle determined by the vectors 8, 4, and 7, -3. So again, I'm going to make a matrix. So I get 8, 7, 4, -3. And then I'm going to find the determinant of T, and that's the absolute value still. So I have 8 times -3 minus 7 times 4. So that gives me -24 minus 28, which is -52. And the absolute value of that, of course, is 52. So I'm going to take the area of the triangle is 1/2 the absolute value of determinant of T. So 1/2 times 52 equals 26 square units. Example 5, use a determinant to find the area of a parallelogram. What is the area of a parallelogram with one vertex at the origin and defined by the vectors 5, 7, and 2, -5? So I use the origin as the initial point for both given vectors. Then I graph a copy of each vector starting at the terminal point of the other to complete the parallelogram. So the area of the parallelogram formed by the vectors is twice the area of the triangle, so area of P equals the absolute value of determinant T. Using the matrix T equals 5, 2, 7, -5, the area of the parallelogram is the absolute value of determinant T. In this case, the determinant is 5 times -5 minus 7 times 2, which gives me 39. So the area of the parallelogram is 39 square units. Parallelogram has one vertex at the origin, is defined by vectors -2, 1, and 1A, and has an area of 5 square units. What are the possible value or values of A? So I create my matrix, -2, 1, 1A. I set up my determinant, -2 times A minus 1 times 1, which equals 5. So -2A minus 1 equals 5. So negative 2a minus 1 could equal positive 5, which would give me negative 3, or it could equal negative 5, which would give me 2. I check both answers. Both answers do give me positive 5. So A could be either negative 3 or 2. All right, let's try it. Find the area of the parallelogram defined by the vectors 3, 8, and 1, 4. So again, I'm a matrix T. I'm going to find my determinant of T, which is 3 times 4 minus 8 times 1. Of course, this is still the absolute value. I have 12 minus 8 equals 4. So the area of the parallelogram is 4 square units. Okay. Concept summary, matrix inverses and determinants. So my determinant, the determinant of a 2 by 2 matrix A equals A, B, C, D is denoted DETA and is equal to AD minus BC. If A is an n by n matrix with n greater than or equal to 3, I use technology to calculate the determinant. Inverses. The multiplicative inverse of a square matrix A denoted by A to the negative first power exists if and only if DETA does not equal 0. It is a unique matrix such that A times A, the inverse of A equals I, where I is the identity matrix, and the inverse of A times A equals I. For a 2 by 2 matrix, A equals A, B, C, D. The inverse matrix is the inverse matrix equals 1 over the determinant A times D times the matrix D, negative B, negative C, A. If A is an n by n matrix with n greater than or equal to 3, use technology to calculate the inverse matrix. Applications. The area of the parallelogram defined by vectors A, B, and C, D, and the matrix P equals A, C, B, D is given by the absolute value of determinant P. So for example, for vectors 4, negative 3, and 6, 7, my matrix P becomes 4, 6, negative 3, 7. The determinant P equals 4, the absolute value of 4, 6, negative 3, 7, which is 28 minus negative 18, or 46. So the area of the parallelogram is 46 square units. The area of the triangle defined by vectors AB and CD and the matrix T equals ACBD is 1/2 times the absolute value of the determinant T. So for vectors 2, 3, 6, negative 2, my matrix 2, 6, 3, negative 2 becomes 1/2 times negative 4 minus 18, which equals 1/2 times 22, or 11. So the area of the triangle is 11 square units. And that is the end of Unit 10, Lesson 4.